じですね。で、彼女、ステファニー・ネメスさんです。ステファニー・ネメスさんはですね、普段はアムステルダムに住んでいて、Are you working for Microsoft? マイクロソフトで働いているということです。で、結構 JS-CONF.EU で見たこの一回発表を見たんですけど、その時もものすごい面白かったんで、ちょっとぜひ期待してください。すでにちょっと面白いと思うんですけど、はい、じゃあよろしくお願いします。じゃあ拍手で。
Hi, thank you. I'm a bit. Hi, welcome. Sorry. Hi, welcome. Is it okay? Okay. I'm a bit jet lagged, but I'm just going to pretend I'm super energetic because I am really happy to be here. So I'm just going to try to keep the energy high up. Thanks for coming to my talk. Yeah, about me. I'm originally from the US. I lived in Amsterdam for 4 years. That'll be important in a minute. But I just moved to Berlin. I'm a software engineer now at Microsoft, working on the Microsoft To Do app. And I really love front-end, CSS, React, and accessibility. As you can probably tell, I really like to build fun things with LEDs. Like, this is my dog's son, Wilbur. And even though he's playing it like very cool, he actually really loves it when I put on the LED rainbow dog collar I made for him because, I mean, he gets all the attention, so he loves it. So never mind his like poker face. But I really didn't know that I like to build stuff, fun stuff with LEDs until recently. I'm actually a hardware newbie. I've only been working with hardware for about the past year or so. And I really got started in hardware because I went to the Stedelijk Art Museum. This is in Amsterdam. It's a modern art museum. And I got inspired there. I went to see this exhibit by this artist. It's a Swiss artist named Jean Tingley, who was mainly active in the 60s and 70s. And for him, art was not about standing in a sterile white space and distantly gazing at a painting. Art was meant to be interactive, and it was meant to be playful. And he created these art sculptures that could be triggered by the viewer, like this one. And what happens with the sculpture is a viewer can go up to it and put in a writing utensil here, like a pen or a pencil. And then there's like some way to trigger the art into motion with like the button. And it creates, this art piece can create an entirely new piece of art. And it was no longer about just watching the process. The viewer, by choosing the pen or pencil, played a central role in creating an entirely new work of art. And this really appealed to me. And when I was at the exhibit, I saw this quote. It says, "I wanted something ephemeral that would pass like a falling star. The word just had to transpire, make people dream and talk, and that would be all." And I really like this idea of creating this really temporary art experience that's spontaneous and it connects an artist with the viewer. And it's only meant to bring joy and inspire for a really, really short amount of time. So I was really excited by all these ideas. But I had to figure out a way that I wanted to use my developer skill set and make my own interactive art experience. And I live in Amsterdam. Apartments are pretty small. I had a really small apartment, so I didn't really have room to make this big installation that would be interactive. So I decided to apply the same idea of interactivity to the most accessible form of expression I could think of, which is my clothing. So this is actually the entire outfit that I created. These are some of the pieces. The skirt kind of couldn't travel very well to Tokyo, so I made this headpiece instead. But I really wanted to make this cohesive, complete look that was completely interactive with users through a web app. And I was really interested in the interactions that would occur when people realized that they have complete control over how my outfit looks, and the light patterns and the colors. So to start with this project, I had a plan, and my first thing I needed to build was I needed to build a web app that users could go to a web address and click different programs and colors and send that to the hardware. Then I actually needed to make the hardware. So I needed to integrate these LEDs and microcontrollers to control them and receive those messages into different pieces of clothing. And then I needed a way to communicate from the web app to the hardware. And for me, maybe you've heard of this library, Socket.io. It's one of my favorite libraries. So I decided, since I was already familiar with it and knew a bit about it, I would just use it because, why not start with something you're comfortable with? So I was going to, integrate the Socket.io clients into both the web app and then on the hardware, and then that would relay the messages back and forth. So I felt like really prepared. I had a great plan, but I actually faced a lot of challenges. This is what I'm going to spend the rest of the talk talking about. And don't worry, you'll get a chance to play with my LEDs in a bit. I faced a lot of challenges because I had followed some tutorials. I don't know if you've heard of Adafruit, but they have a lot of tutorials if you're starting out with hardware. I made like some simple earrings just by following instructions. That was really the extent of me building with hardware, was following instructions. And so this would be the most ambitious project I have ever tried out, because I would be completely coming up with the plans and the wiring myself, and then doing all the programming. But really, building stuff is all about iteration. I had a lot of setbacks. It made me unsure if I was a good coder, if I was a good working with hardware, if I could ever be better at any of these things. But most importantly, I just tried to learn from each of the setbacks I had and continually improve my project to get it to where it is today. So let's just start at the beginning. So like I said, I wanted to create a simple web app. This is just kind of a schema of how my project, the flow would look. So I have a web app with Socket.io client. Users can pick like a program like Rainbow Rain, for example, that goes to Socket.io server, and then that message would get relayed to each of the to the hardware that had Socket.io clients integrated. Since I kind of felt like I had a handle on the software, the coding bits, my focus was really at first on getting all the hardware working. And I needed to figure out what I was going to use to control the LEDs in my clothing. And I had a few requirements. It needed to have a small footprint. That means it needed to be really small in size because I didn't want it to really stand out in my clothing and be bulky. It needed to be durable because I'm taking it on and off. I didn't need it to break after the first time I wore it. And I also needed Wi-Fi connectivity because that's how I was going to relay the information. I was going to have the hardware tethered to my phone. That's what it's doing right now. And then it would just use that Wi-Fi to receive messages. So I decided to go with Arduino, and I chose the Adafruit Feather Hiza. I chose it because it's Arduino, it's small, it has Wi-Fi built in, but the main reason is there's a lot of info and tutorials online. People really like this microcontroller. It's really versatile. So I decided if I got stuck, then I probably should go with something that a lot of people have had experience with, so I could find information to help me out if I got stuck. So I moved into the building phase, and I just kind of want to show this to debunk the building is not glamorous. It's very unglamorous. It's me. Like I said, I had a really small apartment, so I was just crouched over on my floor, soldering, and then realizing I had soldered things wrong, and then unsoldering, and resoldering them again, and just testing things out. And if you're thinking about getting started baking, I would really suggest making a wiring diagram before. And these are, for example, the one on the left is for the umbrella, and this is for the necklace. And this was my roadmap, and I just created these using Fritzing. It's a free program. You can import all these different components and make wiring diagrams. This saved me so many times that I created this basically a roadmap before I started building, because when you have all these wires hanging out, it gets really confusing and it's easy to mess up. So once I got finished building and it was working, I didn't want to have to give much explanation to the people, the viewers, the people I would be interacting with on the streets of Amsterdam. So I printed these cards that basically said, my outfit is interactive and it had a web address. Because I didn't want to have to explain it. I wanted people just to experience it without any context. Yeah, so my first outing is in Amsterdam every year in the winter. They have this lighted bike ride, which is really fun. I want to show you just a quick little video. So as you can see, everything's going well, and then you see that green line on my skirt? That's not supposed to happen. That was my skirt rebooting. And you can see it's out of sync with the program on the umbrella, and the necklace is different. The loop again, you can see they're all in sync. It crashes, it reboots, and it starts with the default program, which is the Sparkle program, similar to what I have on now. And everyone thought it was great, but all I could see was this is a huge failure. This was not supposed to happen. So I was super embarrassed, and I was disappointed, even though it was a big hit at the bike ride. People thought it was magical, but all I could see is like my necklace would crash, and then my skirt would crash, and it was just like very frustrating. So I just used that as an opportunity to debug and figure out how I could make it crash less. Because I wanted to take it out again and have like a more positive experience with it. So I needed to find out where the hardware is crashing. So with this Arduino board, it has the serial monitor, so when you plug it in with USB to my laptop, I get kind of like a log console. So I did kind of like what you might do in JavaScript sometime. I just, in my Arduino code, I put in a bunch of print statements so I could see like where exactly in the program it was crashing. And what I found it was, the problem was it kept losing its Wi-Fi connection. It kept disconnecting and reconnecting, and that's why the program kept rebooting. So it started making me think about like the tools I was using to build my project. And although I am a huge fangirl of Socket.io, it is a great, versatile library. I had to think about, you know, it's great for the web, but was it really the best choice for my IoT project? It's made for web applications to communicate over HTTP, and it's geared more to browsers, and I really didn't need that extra overhead. So I just took a step back and thought about what I was coding up against when you're coding for hardware. And just because a library is available doesn't always mean it's the best solution for your project. So coding for hardware, these are small boards that I'm using, and they don't have a lot of resources. And because I wasn't communicating between a browser and a server for my hardware, maybe I didn't need that extra overhead that is required of HTTP. I really need the bare minimum, but easy to implement and understand messaging library. And that's what I found out about MQTT. Now, MQTT is not new. It's been around since 1999, but it wasn't new to me. It's a lightweight messaging protocol optimized for high latency or unreliable networks. It was originally developed when engineers needed a reliable way to send data from remote, like oil pipelines in Africa to satellites. And I could really give a whole talk about MQTT because it's a really great protocol, but I just want to highlight the things that I thought were most awesome. So it's based on the publish-subscribe architecture, so there's clients, and then there's a broker in between them, and the clients connect to the broker, and that mediates the communication between devices. What's important about this architecture is that when the device connects, it connects to a topic. So when I have it connecting, it just subscribes to topic lights, and then it can, whenever there's a message that's published with the topic lights, any client that is subscribed to that will receive it. And what's really nice about MQTT is that the publisher and the subscriber don't need to know about each other, and they don't need to run at the same time. And operations on both aren't halted during publishing or receiving. It's super lightweight. It's transport over TCP. And what that really means is that in comparison to other protocols like HTTP, it does not load the network with the transfer information that is just necessary for the protocol to run. And it has a 2-byte overhead, which is really small, and it's really great for IoT. It just lowers like the amount of data that's transmitted over possibly constrained networks and devices. It has a very short and readable spec. So they use simple verbs in English to describe the actions, and there's basically 5 verbs in MQTT. Connect, disconnect, publish, subscribe, and ping, and that's it. So I just decided to give MQTT a try. It sounded like really what the solution for my problem. So I needed to rework the app. So it means I needed to change out the Socket.io server to an MQTT broker, and then switch out the Socket.io clients in the hardware and the web app to a MQTT client. So I started with the web app, and there's a really great library called MQTT.js. And it's really only a few lines to implement. This is just my abbreviated code here. So basically you just include the library here, and then you create a client that connects to the broker. So you just tell it where the URL for where your broker is. And then you can have it, so for example, this is would be like the web app sending the messages, the programs. So I just, for example, have a button on the DOM, and when it's clicked, I have an event listener that sends this event rainbow, and that function just publishes to the MQTT broker with topic lights, and then the program, which is just rainbow. Next is setting up the Arduino clients. And don't worry if you're not familiar with Arduino code. It's kind of like C++. It's very similar. But the main thing in Arduino is you have a setup, and then to run your code, it's just running a loop the whole time. The program's running after the setup. So it's very similar. You just include the library again, and then I just need to tell it where the URL for where the broker is. And then the step that's different here is actually subscribing to a topic here, because we wanted to receive messages. So subscribe, and then whenever it receives a message with that subscribe to that topic, then it can do this on message, and it'll can call a function to do something with that information. So everything was going really smoothly. I set up my client, so setting up the broker, this should be easy. But there's one thing you should know is that I had this all deployed on Heroku. I'm not the greatest at DevOps, so I love Heroku. It's got a great CLI. It's very user-friendly, but that comes at a cost because for MQTT protocol, I really need access to ports 1883, and Heroku just doesn't let you have access to ports, so that wasn't going to work. So I either need to move to another service to host it, or I started looking at if there's an external MQTT as a service I could use. And there's some, and I found one, Shifter.io. It's this IoT prototyping platform. It's free, it's easy to set up. It was free, that was very important to me, so I just decided to go with it. And it works great, but I wasn't ecstatic. I wasn't super happy because I was relying on this external service that I didn't know that much about. They don't really have a big Twitter following. I didn't know, it just didn't seem didn't sit well with me. It didn't seem reliable. So you can probably guess what I did next is, I built my own MQTT broker, and that just meant I needed to move my web app server and my MQTT broker. I needed to move it to a different hosting service, so I moved it to DigitalOcean. And I used this library called 80s. It's just an MQTT broker written in Node, and what really appealed to me about this broker is not only it's in JavaScript, is that I could completely embed it into the Express server that was serving my web app. So it would just be really an extra line of code to handle MQTT in addition to serving my web app. So to implement this, like I said, I have my Express server. Really, I just include the 80s, and then you create a MQTT server for handling those connections, and you let it know it needs to listen on port 1883. And this is the line I was talking about. I just simply augmented the HTTP server that's serving my web app, the site, and it just uses WebSockets to handle all the requests coming in for the MQTT for the messaging. yeah, so I was super pumped. I work at Microsoft now. I'm going to use this as much as I want now. And I was really ecstatic. But I wasn't done yet. I wanted to make it really rock solid, and I always kind of have to look down to make sure still things are working when I say this. I really wanted to make it really solid and that it wouldn't break, so I decided to upgrade my microcontroller. And I upgraded to the Feather M0 Wi-Fi, and I did that because it has low power management, which is great. The main reason was it has a separate Wi-Fi module. And yeah, it just gave me high-speed, reliable Wi-Fi because it didn't have to yield on the Feather Hizza. They were on the same processor. And with this one, because they're on it's in a separate module, it didn't have to yield all the time to the Wi-Fi port. So it makes it a really rock solid. The downside is it's twice the cost of the Feather Hizza. So in euros, this microcontroller, the M0, is around 35 euros, and the Feather Hizza is around 18 euros. So it's about twice the cost, but it gave me a lot of peace of mind, so I was willing to make that trade-off. So here's the fun time now. I want you to interact with my outfit, and let's see how this goes. So you can go to flashylights.nl, and yeah, select a color, select a program, and send it. I'm waiting for someone to be the first one. Helpful, better wants to do. Yes, there it goes. Yeah, so just keep sending messages. And by the way, this is the last time I'm giving this talk. So this talk and these wearables will be retired. So this is the last time that I will leave the app. Well, I'll probably use the umbrella for fun, but I won't be using it for talks anymore. So while you're enjoying this, I just want to close with my kind of closing thoughts. That this is a really weird experiment to do as an introvert. You might not realize, but I'm an introvert, even though I'm standing up here. Attracting attention to myself and seeking out to interact with people is way outside my comfort zone. But it was an experiment that really pushed me to deal with my own reactions to people's reactions. So that was interesting, and it made it worthwhile, even though it is weird to have people staring at me, which it's kind of hard to imagine that, but yeah, it's been uncomfortable for me. So that's it. I just want to thank you. If you want to contact me, you can go to my website, stephanie.ll. I'm Stephanie Coes on Twitter. I brought chocolate from Berlin. Please, I have 2 Kinder Eggs. Please come get some chocolate for me before I'm easy to spot. I don't want to take it back. I don't want to eat it either because I don't need to eat any more chocolate. I already eat way too much. So come find me after the talk. I'd love to give you some chocolate. I just have to go get it from my bag in the speaker room. But that's it. Thank you.
ありがとうございました。いや、すごいカラフル。先ほどのステファニーの色を変えられる、服の色を変えられるURL はツイッターにシェアしてあるので、ごちょごちょして多分今変えてるだろうと思います。ですね。一旦ここで全てのコンテンツは次から LT とスポンサートークになります。でその後アフターパーティーって形になりますので、ちょっと一旦休憩します。でここを